Thank you for joining us at Voxtelesys as we discuss network for small business. Now, we're going to cover public internet, router, firewall, switching, how data moves. It's going to be a conversation with some slides to help visualize what we're talking about. This is meant not for the senior network engineer. It's not meant for the person that's gone through 2 or 3 years of networking. It's meant for management and your operations people that aren't necessarily directly involved, so they can understand the complexity that goes into a small business network. It might help you make a better decision when seeking out MSPs. It might help you make a better decision when seeking out new vendors. So we're just here to give you the information you need to be able to have the proper questions or the proper ideas in place when you're talking to people about your future, whether it's voice over IP or video conferencing or remote working or firewall. This conversation is the starting point. It's the basic network. And we're hoping this to be one of many videos in this upcoming series where we discuss how you go from a small business network to a well-configured voice over IP, remote working, firewalled network. So this is the beginning level. This is just the 10,000 foot view of what networking is and how it works. All right, so we're talking basic networking. We're going to go over networking, routing, firewall, and switching. Now, networking is the internet portion of the conversation. It's very complex, but you should probably know this at a high level so that you can know what you're looking for when you're talking to your service providers. So, to start off with that network conversation, let's first discuss what you're moving. So, OSI is the model that was created many years ago that describes how we move data from computers to computers, how we move data from phone to phone. It covers it all. OSI model consists of 7 layers. The first layer is the layer that converts your signal into binary, or your binary into signal, and puts it on the medium, fiber, copper, wireless, whatever that is. It's the conversion of the packets and frames into those binary bits that drop onto the physical network so that you can move from one location to the next. Layer 2 is the hardware addressing or the MAC addressing of those frames and the data link layer. It's how the data physically moves inside of a switch and gets to where it needs to go to move to the next location. Layer 3 is the routing layer, most referred to. It's how data moves between domains. It's how it's responsible for the transmission of the segments across and between networks. And so layer 3 is extremely important when it comes to public internet and routing. Layer 4 is a segmentation. It has some error correcting in it. It performs sequencing. It's responsible for the TCP and the ports. It's very important for how voice works. So for example, SIP is on port 5060 using UDP. That's all assigned here at layer 4. Layer 5 is your synchronization and acknowledgement layer. This is also where jitter and some of the delays and stuff is handled at. Layers 6 and 7 are your application layers. The presentation application, it's how you encrypt data. It's the data presentation, the application layer, SIP, HTTP, FTP. It's the actual application that's creating that data packet that's being put onto layer 1. So in the world and how we deal with data, you start at layer 7, then you go to layer 6, and then you go to layer 5. It goes to 4, 3, 2, 1, and then 1 transfers to 1, and then 1, 2, 3, 4, 5, 6, 7. And that's how data moves from one computer to the next. So the public internet is quite complicated. As we discussed in the OSI model, we're moving things between layer 7 and layer 1 and back up to layer 7. Well, the public internet is pretty much the movement between layer 1 and 3, maybe some 4, but layer 1 and 3 typically. And so let's talk about what we're moving. We're moving IPv4 and IPv6. So IPv4 is a 32-bit address. Is written as a dot decimal notation. It consists of 4 octets. You've probably seen like a 10.10.10.0/24 network, or you've seen a 192.168.0.1 network. You've heard someone talk about it. And it's a A.B.C.0/24, 8, whatever that is. That network is your, that IP address is what most people use today. It's what most people think of IP as. It also has a CIDR, which is your classless internet domain routing. It's the subnet that is used to route between networks and create broadcast domains, etc., etc. IPv6 is much bigger. It's 128 bits. It's broken to 8 16-bit hexadecimal segments. The first 48 bits are internet routing. The next 16 bits from 49 to 64 are for your subnetting, and the last 64 bits are for your device or your interface IDs. It's actually quite simple. I like it a lot. We're not quite there yet. In fact, when I took my first Cisco course 25 years ago, IPv6 was going to be just around the corner, and we're all going to be using it. Well, that was 25 years ago. So we'll get there one day. But IPv6 is, when we're talking public internet, that's what the public internet is transporting. So the public internet runs off of BGP. That's the Border Gateway Protocol. And the way that works is that IPv6 is and IPv4 are transported by an AS number advertising out, I have this IPv6 network, or I have this IPv4 network, to other ASs, who then advertise that to other ASs, so that when you want to get from network A to network B, the BGP network knows about it, and it can tell you how to best get there. So it's fault tolerant, it's quite robust, it's been around forever. Yes, China has broken it in the past. Yes, Level 3 and CenturyLink have broken it in the past, most recently. And when you have national outages, usually it has something to do with a BGP problem. So BGP is the routing protocol, which is used to move the IPv4 and IPv6 across the public network. What it doesn't do is move the non-routable networks, like RFC 1918, which is your 10/H, your 172.116/12s, or your 192.168/16s. It also doesn't move your loopbacks, your 127/H, or your FC00/7s. Those are all internal. Those are non-publicly routed. It also doesn't route your boggin addresses, your 6809s. Those are IP addresses that, excluding 1918, that are not yet assigned or are in some way restricted from public route. So it's very important that you understand what IPs can be routed and can't be routed, and it's very important that you don't use the wrong IP space or network space in the wrong network. So make sure you have a good understanding of that. Just as a quick example of how AS and BGP works, you can use MTR with a -Z configuration, and it will give you your BGP output. I'd like to just let me run a quick trace for you so that you can see kind of how it works, and we'll talk through that real quick. So the way that we're going to test this is we're going to type in your MTR space -Z space the IP address you want to trace. So what we're seeing here is that we're going out my gateway, which is, this is going to be my firewall. Obviously, it's an internal IP. It's not going to have an AS number. And you can see my carrier, idea 1. They have the AS number of 12042. That 12042 are the first 8 hops. So idea 1 takes 8 hops to leave their network. We then go to 3257, which is GTT. And then GTT hops over to hop 11, which is 15.16.9, and that's going to be Google. And so there are 3 ASs between me and Google from this hop. You can run this trace to multiple networks, and it should move around depending on what the route is. You can see here, we go out the idea 1 then to our Eventus, and then we go to GTT, and then we hit Cloudflare at 1.1.1.1. Okay, so this is a pretty simple tool to understand how it works. The AS is a different company's network or a different router. So you can see I'm hitting 3 different companies: Aventus, GTT, and then the 1.1.1.1, which is Cloudflare's network. It's a pretty cool example of how this all works. So now let's talk about the routers. So a router is what your ISP is going to hand off to your network. It's usually a physical device. It can be referred to as a modem, so cable modem, a network router. Most ISPs are going to hand that off to you. Now that is usually interconnected into their network, which is most likely BGP, using an AS number, using a static route. And that's another form of routing, but it only knows what is on the other side of it. So the router on the far end has to know what's on the router of the far end to be able to get there. So in this case, we're going to set up the carrier, and this isn't always going to be the case. Routers can, internet providers can do whatever they want between their modem and them. It doesn't have to be public and be private. They can do a lot of interesting things to achieve the goal of routing traffic from that modem router to the public internet. But that's on their side. It's not your responsibility. For this conversation, we're going to show it as a /30, and it's going to be 1.1.1.2 and 1.1.1.1. Now that means that the router can now route to the public internet. It's pretty simple. There's nothing complicated there. That's a static route. Now the next phase is the firewall. So this is going to be your device in most cases. There are some carriers that are going to give you a firewall modem combo. If you are a small business and you're doing that, you don't want to be doing that, because that means that they have put the least expensive, lowest common denominator device in your network location, and it may or may not serve your purposes. And I do not recommend using it. I recommend you having your own firewall that you manage, or you have a professional manage for you that's separate from your ISP. So the firewall is going to have a wide area network, or a WAN network interface. That is going to be connected to the router/modem. Now, this needs to be a publicly routable network space. I'm describing this here with a IPv4 network, so that's 1.1.2.1 is the modem, and 1.1.2.2 is the firewall. It's a /30. You can route any network across to the modem, which will then route out to the BGP or the public internet. It is super important that you're using a publicly routable IP on your firewall, because otherwise things like voice over IP or video conferencing, VPNs, those things that make the remote networking workable become very unworkable and problematic. In a lot of cases, they just don't even work, or they work so unreliably no one uses them. So you want to have that static as well. They sometimes will give you a DHCP address. DHCP means that IP address is going to change from time to time. Well, if you are on a DHCP route, what that means is that every time that IP changes, you're going to have to do something inside your network to let everyone know that your IP changed. Now, there's a lot of mechanisms to do that, but it's always easier and smarter to run a static IP so that doesn't change, so you don't have a period of downtime while that information is worked out. Every firewall has a local area network. It's a LAN. So this is where you're going to be placing your NAT to get to the public internet. It's also where your IP access lists come into play to allow certain things to route in and out. On the conversation of NAT, I'm just addressing the masquerading. I'm not doing one-to-one or port NATs. Masquerading as a full cone NAT. If you're going to be doing one-to-one NATs for specific devices like a file server or a voice server, you're going to want to have a unique IP address for each one of those devices. So you can order multiple IPs from a carrier. In this case, I show a /30, but you could easily order a /29 from that carrier and then be able to assign unique IPs to each one of those devices behind your firewall. That is the proper way to do it. For this demonstration, we're just going to be talking about the masquerading component. So the firewall does your NAT masquerading and your IP access list and rules. An IP access list You can say, I will allow from this IP, or I will allow from this host name, or I will allow from this port, or I will not allow from these things. That's what an access list. It's basically you have access to these things in and out. You can put it on either interface. Most of the time also, your firewall, and once again, we're talking small business. We're not talking these large organizations which have multiple services, but for small businesses, most of the time, if you have a firewall, it will support DHCP. So you're going to put the DHCP server or the dynamic host configuration protocol. That's how you get your internal IPs. That's when you plug a device into a network and all of a sudden it gets an IP address and it can talk to the world. If that doesn't work, you don't talk to the world. So most people put it on their firewall. Once again, if you're running a local area network, this needs to be a non-routable IP or an RFC 1918. I had a client a long time ago that used the 1.1.1.1 network or 0 network /24. The problem is that's Cloudflare. And so because they used that, they couldn't use the Cloudflare DNS, and they had products that required it because they were using a routable network. Don't do that. That's very frustrating for everyone involved in troubleshooting that problem. So make sure that if you have a local network that you're using a privately non-routable network that gets converted via NAT, and that's going to be your 1918. Now, if you still are like some of these legacy companies that have the money to spend, $15,000 on a publicly routable IPv4 network space, and you want to run that on your local area network, more power to you. But you have to own that network and be able to advertise that network out. Otherwise, for the sake of your small business, it won't work. So once again, LAN should be an RFC 1918 network or a local network, and you should make sure that you're properly configured with a NAT to a public IP address and static. Okay, switching. Now this is always kind of a fun conversation because switching is pretty simple. A switch is just a device that you plug a cable into. A lot of times switches are part of your firewall. I don't usually recommend that. I recommend having a separate firewall that's not your switch. I know there's a lot of good products out there that combine the two, but if you want a really stable network, I always recommend getting a dedicated switch, managed switch, and a dedicated firewall. The difference between managed and unmanaged is a managed switch has features that you can go in and get out. So switches are typically layer 2 if they're unmanaged, and layer 3 if they're managed. If you're running a layer 2 managed switch, it just gives you things where you can change bit rates. You can classify ports. There's do classifications for making sure you have DSPs properly set right for your quality of service or your QS tagging. You can do VLANs, but you want to manage switch. Even if it's just a layer 2, you want to manage switch. But in this case, we're just going to describe this as a unmanaged switch. And guess what? If it's an unmanaged switch, you're still using a default VLAN. I know people will argue this, but what it comes down to is that the 0 VLAN is always your default VLAN on any switch. Now, it doesn't have to be 0, but in unmanaged, because there's no way identifying it, it's going to be the 0 default VLAN. So that switch, every port on that switch is at 0. So it's a 0 default VLAN. If you plug in the LAN port into any port, it will advertise out on those ports because of that VLAN. It's that simple. There's nothing more complicated about it. So now we're going to be talking about how it all comes together. So if your switch supports PoE, most switches do these days. If you're running voice, you're going to want to use a PoE switch because most phone devices that plug into switches will use PoE. That's power over Ethernet. So you're going to plug your phone in. It's then going to power up because of the PoE. Once it powers up, it's going to then get a DHCP configured host protocol IP address assigned to it from your RFC 1918 network that you programmed into your firewall. It's then going to boot up and come alive and say everything's hunky-dory. You're then going to plug in your computer into the back of your phone because most modern voice over IP phones have a port for your computer. You plug your computer into it, and now your computer is going to get an IP address. It's going to come up and say, I'm alive, and everything's going to work. So Bob's your uncle. We're off into the races. You're now sending phone calls, and you're sending internet traffic, and everyone's happy. So I hope this simple explanation of how network how your networking works and how everything kind of plugs together might help you in making decisions moving forward. The next video, we're going to maybe discuss how we put together a voice network inside of this basic networking and how it might work for you.